The Evolution Application Prize is out. Mr. Bergen has sent 21 professional students out into the world to find 5 ancestors of a species. The journey will be a difficult one, traversing through dead-end searches on Google, technical errors, low battery, and ancestors that refuse to be discovered. Luckily, Benjamin Stevenson, a trained archaeologist/researcher of St. Michael's College School, was put to the challenge of finding 5 ancestors of a species. Which species, you ask? The leopard. Time to understand the leopard before going into the deep dive of ancestor research. Leopard, or Panthera pardus, come from the domain Eukaryotic, kingdom Animalia, phylum Chloridata, the class Mammalia, the order Carnivora, the family Feline, and the genus Panthera. Panthera pardus live in grassy plains, savanna, and deserts of Africa, the mountains and rainforests in Asia. These powerful carnivores eat a huge variety of food, including fish, carrions, birds, reptiles, rodents, antelopes, hares, warhogs, and baboons. Leopards are incredible hunters with a smart strategy of stalking their prey as opportunists when the prey is vulnerable to a pounce. Leopards are fast, strong, have incredible bite force, and have a great jump. Their paws alongside their big claws allow them to climb trees with ease. All these descriptions of the leopard are traits that have been developed and evolved over millions of years. In this adventure, we will be focusing on finding the 5 most important ancestors that made the leopard the leopard. Going back 63 million years ago, when my parents started to walk the earth, the world was a different place, which explains a lot about my parents. Moving on, a creature thrived in the depth of the rainforests in Europe, Asia, and North America. This creature was the myosid, hunted in a similar way to leopards, even though it was half the height, coming in at around 30 centimeters. This little feisty guy would evolve into all cats, dogs, bears, skunks, mongoons, and hyenas. All these creatures mentioned that live today share homologous structures with the myconid. While myconids share the same bones as these species today through legs/limbs, but have different purposes, I actually think there is a more interesting homologous structure, as the myconids is credited with evolving into all carnivores. Today, looking at the homologous structures of teeth is much more interesting. The myconids were probably the first to have the carnassial tooth. This carnassial tooth is found in dogs and wolves to eat prey like deer. The carnassial tooth is found in hyenas that almost eat anything from carrions, big prey, vegetables, and feces. Oh, gross. Bears also have very large carnassial teeth, and skunks have very small ones. Most importantly, cats also have the carnassial tooth, which of course is found in the leopard too. This means that the myconid is an ancestor of the leopard, as they have a common trait that is in fact passed on. These carnassial teeth are used as humans use molars, but the carnassial teeth have one primary use. As it is located further to the back of the mouth, being wider and thicker than other teeth, it is designed to break through bone and difficult muscle/fascia. The carnassial tooth of the myconids has helped it to break the bones of birds, lizards, and small mammals, which is guessed to be its diet. Why this is a homologous trait is because they all break down different food, and all the prey that they eat have different bones, but they all share this carnassial tooth. Moving forward 40 million years in 3, 2, 1, boom, another ancestor of the leopard lived. The Prylaris is actually the ancestor of all cats. It lived in Asia and Europe, which is similar to where the leopard lives. The important thing, although, is the Prylaris had a tail, fur, binocular vision, the same dental structure, and similar diets. This is very significant, as these traits will be passed on to all cats. Cats came from the Polaris, and most cats look very different and do different things. Adaptive radiation must have happened. In particular, divergent evolution happened. The Polaris did exist as a species 25 to 20 million years ago, and did evolve into a variety of species. This means that the species would have spread into different species, creating genetic diversity. In total, there are 42 cats in the family Felinea, which are the felines, and that is only accounting for the alive ones. Many have gone extinct, as we will continue to see in a moment. The Polaris evolved and branched out into lions, house cats, tigers, and of course leopards, to name a few. This branching out is divergent evolution, and is proof of adaptive radiation. While each species still has all the same things that the Polaris had: 4 limbs, vertebrae, warm-blooded, fur, a tail, eyes with binocular vision, and a similar dental structure, diet, and have similar teeth throughout all cats/felines, they have to have these features, but all have differences. The proof of this is that the species that branched out live in different regions, eat different food, have different appearances, and different lifestyles. For example, lions live in the savannas of Africa, eat zebra and wildebeest, have a beige fur, and males have a great amount of fur close to their neck and heads, and live in a pack of lions. Snow leopards live in the mountains of Asia, eat carrions, and most other prey they can find have whitish fur, and live along in solitude. House cats have domesticated into human civilization, eating mice and, in the present, cat food. They are small, coming in a variety of colors and patterns, and mostly now live as pets or on the streets of cities in all around the world. The divergent evolution of Felindia is from the Pliosaurus. The Pseudoloris lived 20 to 8 million years ago and is the ancestor of all felines. It had a similar skeleton to all felines living today and was the first feline to move to North America, but also lived in Asia and Europe. A cool thing about the Pseudoloris is it had rosettes like the leopard and lived in the same areas hunting and living in similar fashion to the leopard. The only difference was the Pseudoloris was 55 centimeters tall, whereas the leopard was 70 to 80 centimeters tall. While the Pseudoloris seems to be short compared to the leopard, like anyone in class compared to me, it is significant to note that this is a huge height difference compared to where it came from, the 30-centimeter mycenete. Becoming taller is a key trait in differentiating the Pliosaurus from its ancestors. This natural selection is in perfect action. The environment around it is becoming less rainforesty, making big savanna plains and more open forest. This means prey can survive more based on speed than stealth. This obviously happened very slowly, as Lyell would note, but it did surely start to change. To accommodate for this, the Pliosaurus evolved into a bigger and faster species. This is the Specialoris. The form of natural selection is directional selection, as the feline gets bigger and bigger, faster and faster, taller and taller. The leopard continues this directional selection as it is also bigger. Moving forward again to the Coelodome, living in North and South America as north as Alberta and as south as Chile, as close as 10,000 BC ago. The Coelodome was more commonly known as the saber-toothed tiger. Even though it had the word tiger in its name, it actually is more related to the leopard than the tiger, even though it is related to all big cats, like the lion, tigers, cougars, Siamese, leopards, and all other living big cats. The Coelodome was the biggest feline ever and had huge frontal canines that most paleontologists say they probably used for stabbing to weaken their prey, which was mostly bison and camel, but some North American Coelodome hunted woolly mammoths. Coelodome went extinct 10,000 years ago, unfortunately for them and their massive teeth. They went extinct in an extinction event called the Quaternary extinction event. This extinction event mostly entailed large herbivores were dying off and evolving into species like the deer. The Coelodome ate these large herbivores, and so as its food source went extinct, so did it. As the Coelodome was the biggest feline, it meant that it needed more food, so in many ways it got outclassed by the next significant ancestor. This being the Homo theorem. Existed as close as 10,000 years ago, evolved from the Coelodome 4 million years ago, and arguably in many ways was much more significant than the Coelodome. But as this journey has shown me, that is the point of evolution. That's the point of life, to become more successful and adapt. Adaptation and variation are clear to see when looking at the Homo theorem. For starters, the Homo theorem was smaller than the Coelodome and had smaller teeth, which actually allowed the Homo theorem to get more food that was smaller. The Coelodome had an ambush hunting strategy, but the Homo theorem, on the other hand, was built for long hunting runs. They also hunted in groups. This meant as slower and bigger herbivores were extinct and in their place were deer that could run, the Homo theorem was better built to hunt them. Secondly, the Homo theorem showed great adaptation and variation as it lived on almost every continent with life. It lived in North and South America, but also played a key role in moving back to Eurasia and Africa, where leopards live now. Of all the felines, this expansion into new areas is the greatest. This shows how well it was able to adapt into new environments. So, those are the 5 most important ancestors of the leopard. The mycenete, living 63 to 29 million years ago in rainforests, had many homologous structures like legs, bones, and the carnassial teeth, with all carnivores, which plays a huge role in setting the base for what leopards are. Then the Prolaris lives from 25 to 20 million years ago and is the first carnivore to pack its bones and leave the rainforest. It becomes the ancestor of all cats through huge adaptive radiation when the Pliosaurus goes through a divergent evolution event and has all the vital traits like tail, fur, binocular vision, dental structure, and a diet that leopards live off of today. Then the Specialoris, living 20 to 8 million years ago, ancestor of all felines, becomes taller than all carnivores at the time, which gives it a competitive advantage over others. This is natural selection in its finest, and this trait, being a beneficial trait, goes on to give leopards their height and speed. Coelodome, living 6 million to 10,000 years ago, becoming the biggest feline ever, and completing the height trait, but it wasn't a big runner. Couldn't have made the cross-country team in any means. So, as its big food source went extinct, it couldn't compete with carnivore runners, so the Coelodome went extinct in the Quaternary extinction event, discouraging being so big and encouraging speed. The Homo theorem evolved from the Coelodome 4 million years ago and showed some of the best adaptation and variation, as it was a long endurance runner that could make the running team, as it hunted very successfully. The Homo theorem also lived on every continent that life lived on except Australia, so thanks to it, the big cats are now in every habitat that they live on today. The Homo theorem in Africa would have evolved to be better suited for the savanna, and of course, now the leopard is able to evolve to best suit its habitat in mostly Eurasia. Now, the leopard is a species walking the earth, but it couldn't have done it without these 5 critical ancestors. That is it, the evolution of the leopard. Thank you so much for watching.